Yes, welcome to our channel of Sciences and Mathematics. Today we're going to look at a topic in mathematics which falls under the broader topic of power functions and logarithmic functions. But today's topic is going to pertain to changing of basis of logarithmic functions. We're going to see a procedure in which we can be able to exploit and find a same representative for a logarithmic function but having a different base. So for that case, thank you and welcome. So as I've said, we're going to look at how we can be able to transform, of course, basis of logarithmic functions. So this basically pertains to transformation of basis in logarithms. So suppose we have or we wish to change a particular set of a logarithmic function from one base to another. Then we are going to have a specific procedure that we're going to use for that. And that one we can just use an example in order for us to illustrate that. So suppose we have a logarithm to base of a number just given a start, and we want to transform it to a different base b of that number n. So this is log to base a n, which we want to transform into log to base b n. So our point of interest is those two specific parts of that logarithmic function. Therefore, we're going to use a concept. Of course, we see there is a relationship between logarithms and exponential functions or indices. So therefore, we are going to use that particular concept in order to try and find out how we can be able to go around this set of a problem. So in this case, if we try to look at this second part of a logarithm that we want to transform into, we can say that let log to base n, log to base bn be equal to y. So in this case, trying to look at the relationship between logarithms and indices, and therefore we can say that b to the power of y is equals n. And in this case, of course, if we try to do an operation on this left side and do a similar operation on the other side, that one does not change the value of this. So therefore, we're going to use that concept by trying to introduce logarithms on both sides of this equation, which is going to be the log to a particular base, maybe a, b, y of log to base a, n. So I've introduced log to base n of both sides, as I've said that if you do an operation on the left and right side, which is similar, of course, it does not affect the value. So therefore, it's right to say log to base a by raised to y, or b to power y is equals log a to log to base a n. And in this case, we are going to do an operation that is, of course, applicable for logarithmic or the laws of indices. In logarithm, in case we have a power and an exponent, then we're going to write the left part of the equation as log to base a of n, and then this one is going to appear as a coefficient. So in that case, we are going to have this one as log to base a n, and if we try to look at that, we are of course having that set of problems. So for the first one, it's actually log to base b, which is here. So log to base ab is equals to log to base am. Now in this case, we are going to do a simplification for that by trying to divide or make y the subject of the formula. Now that we are given a representative for y on both sides, we can see on how we can be able to represent y using the logarithms to bases that we have indicated here. So log to base a b. So in this case, we are going to see that y can be represented, this y can be represented as log to base a n over log to base a b. So implying that given we had said log to base bn equals y, then therefore we can do a substitution for y for here and say log to base an over log to base a b is equals log to base b. So therefore log to base bn can be represented as log to base an and log to base ab. So we have transformed this base from log to base, of course, log to base b into log to base a by giving it in a different representation. So that's the procedure that we use for transformation of bases in logarithms, by trying to give it as an exponent, or maybe letting a particular, of course, variable like y, or value like y represent that product of the transformation, and then trying to find logarithms on both sides, and trying to make this variable the value for y subject of the formula, and then doing a substitution now that you are given y is equals to that figure. So in this case, we are going to use a sample question in trying to illustrate how this one can work given a sample problem, so that it complements on what we have discussed. So suppose we are trying to find, or just required to find, log to base 37, then we can say that let log, or maybe express it in a different base, let log to base 37 be equal x. Therefore we can rewrite x and say 3 raised to x in form of we can write this one in the form of an exponential equation. So let 3 raised to x equals 7. So taking logs on both sides, so the log of maybe we introduce a log to a particular base, we can use even our base to base 10. So log to base 10 3x equals log to base 10 7. So using this concept, we can just take this one as a coefficient, which is a log to base 10 3 is equals log to base 10 7. So I've done a rearrangement for the first, the part on the left side. So therefore we can express x in terms of log to base 10 7 over log to base 10 3. So in trying to rewrite that, therefore we can say, now that we are given x as representing this, we can rewrite this and say log to base 37 is equals log to base 10 7 over log to base 10 3. So in finding the values of those ones, we can just read them from the tables and find this log to base 37 is equals to 0.8451 divided by 0.4771, which is a 1.77 to 3 significant figures. So please try to confirm the calculations in this. In any case, of course, we are likely to make an error, but it's good that we may be able in a position, or we are in a position to just find it out and try to do a correction. So in this case, this is the procedure that we're going to use in trying to apply this concept of changing of bases for logarithms, in trying to find solutions to problems like the one that I've shown on the board, given that information. So that is it for today, guys. Thanks. Bye. God bless.